Now we're going to spend some more time looking at systems of equations, solving using the substitution method. And substitution means to substitute or replace one of the variables in your equation with an equivalent expression. And that just means something that is equal to that variable. So the first situation we're going to look at is the simplest to solve. It's when we have y equals form or x equals form on both equations. When we have that, we can just set the equations equal to each other because as I explained in the last video, y has to equal y. So the things that are equal to y also have to equal y, and they have to equal each other. With this new equation that we made, the only variable we have is x. So we're going to solve for x just like we would with any other equation. I'm going to move all of my x's to one side and move all of my things that don't have an x to the other side. And I'm going to continue to solve for x to get x by itself, to isolate the variable. And now we get x equals 3. But again, we're not done. The solution has two parts. The solution has to have a value for every variable. So we have x, and now we need to look for y. Since we have x, we can just plug it into one of the equations that we started with. The bottom one looks the simplest to me this time, so I'm going to go ahead and plug in x equals 3 into the bottom equation, y equals x minus 5. And then I'm going to solve for y. I find that y equals -2, so I can rewrite my solution as an ordered pair as 3, -2. And now we're going to check our solutions. So we need to check the point x, y, 3, -2 for both of these equations. So I'm going to start with the first equation. I'm just rewriting it, y equals -2x plus 4. And then where I see x, I'm going to plug in 3. Where I see y, I'm going to plug in -2. And again, we're not solving for anything now. I'm not moving anything from one side of the equation to another. I'm just simplifying both sides of the equation to see if they really equal each other. We come out with -2 equals -2. And that is a true statement because -2 does equal -2. So I know that at least this point, 3, -2, satisfies the line y equals -2x plus 4. But now I need to make sure it's also a point on our other line, y equals x minus 5. So I'm going to do the same process with that line. So I get another true statement, which means that this point, 3, -2, satisfies both equations. That means that both equations pass through these points. So if we were looking at a graph, then we would see that the lines intersect at the point 3, -2. Now we're going to take a look at what happens when we don't have perfect y equals equations. So if you can see in the middle column, we have y equals x minus 1, which is nice, but then we have -4x minus y equals 2. We can still substitute though, so I need to find all the things that are equal to each other. I have y is the same thing as x minus 1. That's what the first equation tells me. So in the second equation, I can actually replace the y I see there with x minus 1, since that's equal to y. This helps me solve the equation because now I only have one variable, x, instead of both x and y. So here I'm rewriting the second equation and actually plugging in that quantity x minus 1 for y. All right, nothing new here. I'm solving for x like we've been doing all day. Once I find x, I'm going to plug that into one of the equations in order to solve for y. And that top equation looks really easy, right? Because we already have y equals. All I have to do is plug in the x that I found. So that's how I'm going to find my y part of the solution. And again, we can write our solution as a point or an ordered pair. -1, -2. And we check our solutions the same way we've been checking solutions all day. So I'm going to fast forward through that. You can slow it down if you need to look at it, or pause it after I finish the solution so you can look at what I've done. Okay, now this is a fun one. We're going to start the same way we did with the one before. I see that y is equal to 2x minus 5 in the first equation. So that means when I see y in the second equation, I can replace y with 2x minus 5. Notice how I put the 2x minus 5 in parentheses. This is important because we have that negative 2 that was multiplied before the y in our original equation. So we need to distribute that negative 2 across both 2x and negative 5. So when I multiply negative 2 times 2x, I get negative 4x. And when I multiply negative 2 times negative 5, I get positive 10. The hard part is done. Now I have one equation with x as my only variable, so I'm going to keep solving the way I've been solving for x for all the other problems. And then you know what to do after that. We need to find our y, so I'll fast forward through this again. You can pause it if you need to look at what I've done. And then we're going to check our solution exactly the same way as we've checked every other solution. And there you have it, my friends. Now you know how to solve using substitution.